Good morning. Hey,
Hello.
Marino.
Hey, Peter. Hey, everyone. Welcome.
It's what, day 4?
Yeah,
Yeah.
we've got some good momentum going on here.
Yeah, day 4, Thursday, one more day left tomorrow. But today it's all about security, right? We'll talk about securing workloads and just security in general in Istio. And let me just share my screen and get started so we don't waste any time, right? We have I don't have a lot of slides necessarily. I was telling Marino earlier that I could have made more slides, but I think it's better if we show a lot of things just as a demo, right? Practically might make more sense. Let me find this here. Mesh week. There you go. All right, looks good, right? If it doesn't, someone please scream somewhere, so we'll fix it. All right, securing workloads. It's not 11 p.m. It's 11 a.m. I forgot to fix it here, but anyway. So security in terms of what's on in the exam, like in the curriculum portion of the exam, it says that securing workloads is 20% of the score, and there are 3 things listed. Understanding Istio security features, which is very generic, and setting up authorization for HTTP TCP traffic in the mesh. That one is more specific. And the last one is configuring mutual TLS at mesh namespace and workload levels. So that tells us there's going to be mutual TLS. And specifically, since they tell at mesh namespace and workloads level, that's telling us that you have to know how to configure these things at these 3 levels. Oops. So I'll start with this one. Let me just check if I have any notes here. I don't remember. So this is the similar screenshot that Marino showed yesterday. This one shows everything, but at this point, I think we're far enough into all the topics that a lot of things should already make sense here and be familiar. In terms of the security things and those concepts, especially on this diagram, you'll notice down here in STOD, so there's a box here that's talking about, or it says certificate of authority, and there's 2 boxes here that talk about authentication policies, authorization policies. So Istio acts as a certificate authority. The control plane can manage the certificates, and by default, Istio uses a self-signed certificate, of course, right? To sign and issue and sign the certificates for all the workloads that are running in the mesh. Now, this can be configured. You can plug in your own CA if you want, but by default, Istio does that all for you. You don't have to do anything to make this work. The reason the authentication policies, authorization policies are explicitly called out here, it's the same thing as the network configuration, the virtual services, the destination rules we saw yesterday and the day before, right? You're applying those policies. You're applying security authentication authorization policies to STOD in the same way that you're applying virtual services, same way you're applying destination rules. So there's no difference here. They just called it out here.
So I have a question. Is there a relationship between like the virtual service or destination rule resource and any of the security capabilities that you just laid out?
I'm trying to think. Virtual service, probably nothing directly. I'm trying to think. Destination rule, if we talk about destination rule, yes, you can configure TLS settings there, meaning you can configure whether you want the destination to originate a TLS connection, something we'll talk about in one of the demos today, right? So there are a little bit of like things like that, but they're mostly related to MTLS, TLS settings, certificates, right? It's not security per se. It's more of a, I want to configure this things versus authentication, authorization, the policies and everything. Those are in separate resources. So the resources there that are specific to, let's say, security realm, right, are PeerAuthentication, RequestAuthentication, and then the authorization policy, right? And we'll talk about those today. There's also a certificate icon down here, and you see there's a certificate, certificate drawn next to in the ingress box and the egress box, as well in the proxy boxes. And the green lines, the green arrows that you see, those are connections. That's where the communication happens between the proxies, right? And you see that communication is mutual TLS, right? Specifically the one between the proxies. The one between the service and the actual proxy is just localhost, and it's not mutual TLS, right? All right, so let's talk about concepts a little bit. I apologize that there's a lot of stuff on the slides, but it was either having like 20 slides or having like 5 slides with a lot of information on there, so you can take it and use it as like a flashcard if you want to have the concepts in like four slides instead of 50, right? So the first concept is identity. Calling out X509 certificates because these are the documents, the identity documents that are used for identity in Istio. The certificates get issued by Istio-D, the control plane, and they get issued to something called Istio agent. So we haven't talked about this. I'll just mention it. It's not probably important for this certification, I don't think. But so Istio agent is the binary that runs in the sidecar proxy. So that binary is actually responsible for launching the Envoy proxy, but it's also the one that implements the secure discovery service as the SAPI, which the Envoy uses to talk to in order to stream the certificates back and forth. So that's why we're saying technically the certificates are used by the Envoy proxy, but they are issued to the Istio agents, and then Istio agents are the ones who are talking to the proxies. And I'll have an image for this in next slide, I think, or slide after that. So these certificates are a little bit special because they have an identity encoded. So each service has its own identity. In when we're talking about Kubernetes, that identity is derived from the service account. And it gets encoded into the subject alternate name field in the certificate in form of a URL. It looks like this. I have it here: spiffy:// something something, and that something something is the actual fully qualified domain name of the service, right? So it's http://bin.default.svc.cluster.local, right? So that whole thing, that thing is called Spiffy ID, and that's the identity that gets encoded into the certificate. So what the Envoy proxies know how to do is they know how to do the mutual TLS, right? They know how to do the handshake, but they also know how to check for that encoded Spiffy ID, right? And determine the identity, right, that certificate represents. So mutual TLS is another concept. This is compared to the normal TLS when you go and visit a website, right? You go to google.com, solo.io, whatever it is. You see that a padlock on the in your browser. You click on it, and it's going to say that certificate is, I don't even know, connection is secure, right? And then you can click on it, and you can check that the certificate is valid, and you can get the certificate information, right? But that's TLS. That's one way, right? It's the website is not asking me for my certificate to present to it, right? Mutual TLS goes both ways, right? So mutual TLS, in this case, both services or both parties, client and a server, check each other's credentials, right? It's not just one way. So on the client side, service A, service B, right? Service A being the client side, let's say. So Envoy on that side is going to start the mutual TLS handshake. Then it's going to check whether the name in the certificate, whether that spiffy something something is actually authorized to call the other service, right? So Envoy knows the service that we're calling, right? Because we're already issued the request. And it does this check right away, right? So if it's not authorized, it's just going to say, nah, you can't do that, right? The request, once the handshake is done between the client and the server, they establish a mutual TLS connection gets established. And then on the server side Envoy is going to check whether that spiffy something something ID is authorized to make a call to this application. And if it is, it's going to go and forward the request to the application. Otherwise, it's going to drop it, right? The other thing to call out here, and I'm pretty sure this will come up, in the certification because it's one of the interesting features in Istio when talking about security. It's the permissive mode. So permissive mode pertains to mutual TLS, and it's a special mode where the Envoy proxies, the servers, can accept both plain text and mutual TLS traffic at the same time, right? So why is that important? That's important when you're onboarding new workloads to your mesh. You might already have either TLS or mutual TLS set up, right? Or you might not have it either, right? So this just allows you to say, well, let me accept both plain text and mutual TLS for now. Once I onboard these workloads, I can switch over to start making the mutual TLS connection from the client side, right? And then turn off this plain text, switch to so-called strict mode, where only mutual TLS traffic is allowed. The other concept here is more of a not necessarily a concept, but it's more of a certificate management flow. So on the diagram here, this is from istio.io. We have the STOD and certificate authority at the bottom, and then the service with the proxy and that Istio agent binary that I was talking about earlier. So what happens is that when the sidecar container starts, the Istio agent is going to create a private key and a certificate signing request. It's going to send that request to IstioD. IstioD will validate it, and it's going to generate a signed certificate, and it's going to send that back to Istio agent. So once the service comes up as well in the pod, right, Envoy will request the certificate and the key through the SDS API, and then the Istio agent will send over that key. Is going to stream the key insert to the proxy, and that's it pretty much. Then the proxy is ready to participate in mutual TLS. It has the certificate. And in addition, what Istio agent also does is it's going to monitor the certificates for expiration, and it's going to make sure that to repeat this whole flow before the certificate expires, right? So this is basically your certificate management automated right here, right? You don't have to do, there's no participation from the operator, from the developer, from no one, right? As you onboard the workloads, as you start the workloads, all this happens automatically, right? You don't have to change the keys. You don't have to worry about expiration. You can change the expiration date or expiration time for your certificate to a very, very short duration if you want to. You can set it to like an hour, right? And Istio agent will make sure to refresh those certificates periodically, right? So you always have short-lived certificates for all of your workloads in the mesh. Oh, Amim is here. Hey, Amim. It's so odd to hear people being excited for security, but it's always great to have you here. All right. So next to big concepts or blocks, or however we want to compartmentalize these, is the authentication and authorization. So authentication, what does it do? It's an act. What it is, it's an act of validating some sort of a credential and then ensuring that the credential is valid and trusted. Um, so the credentials, we also call them principals, right? We validate that the principals are valid and trusted. In terms of how Istio deals with the authentication, there's a split between service authentication or peer authentication and user or request authentication. At least that's how I map it in my brain. Uh, so the service authentication, it maps to the peer authentication resource in Istio. So whenever you hear or see either peer authentication or someone is talking about service to service authentication, you know that this is service to service, is two peers. It's not users, right? It's services. And as I mentioned, Istio uses mutual TLS, and this can be configured by this peer authentication resource. So the permissive mode, the strict mode, disabling mutual TLS, if you wish, all those things are configurable by the peer authentication. Then on the other side, we have the request authentication that deals with users and requests, right? So this one is used for the end user auth and for verifying the credentials that get attached to the request. This uses JOT tokens, but it also supports custom authentication providers as well, right? So we'll look at this as well. This and basically checks the JOT key. You can ensure that the JOT key that you get back is verified and validated against specific keys, and then you can configure to attach and pass that JOT and the claims over to the requests that are flowing in your mesh. There's something else I wanted to mention here, but now it slipped my mind. I'll probably remember. Yeah, I'll probably remember later on. Oh, yeah, an important thing, right? Which is actually, I have it down here. So both of these things, like service, peer authentication, what do we get as a result from peer authentication is a authenticated principal, which in peer authentication case, you can think of it as a service name, right? Or basically as a service name, right? And then we do the same with the request authentication. What we get there is a principal as well, but that principal is it's not service name. It can be the claims, right? It can be whatever is encoded in that JOT token that's attached to the request, right? And this is important later on for the authorization. So what authorization does is it can answer the question whether an authenticated principal is allowed to perform an action on an object. So can this service make a GET request on the /API path, right? So that would be something that you can control and configure with authorization. But the portion of can that service, the answer to that service would come from the authentication. The authentication would tell you what that service is, right? Yeah, and I have that line here that I almost forgot about. So authorization policy is the resource to configure the authorization policies, and it uses the principles that get extracted from the peer authentication or request authentication, and you can combine them, right? You will see later we can say we can create an authorization policy that says, well, only this service can call that service on these paths, but also when the user that's authenticated has these claims set, for example, right? So you can do one, two, or both, right? All right, let's see if I have more slides. I do, and I think this is the last one. Yes, this is the last one. This is just a quick overview of the configuration. all of the resources, PeerAuthentication, RequestAuthentication, and AuthorizationPolicy can be configured at 3 levels. You can configure or apply those to a specific workload using the selector. You can apply them namespace wide, meaning you just deploy the resource in a namespace without any selectors. Or you can apply them mesh wide, meaning you deploy the resource in the Istio configuration namespace, which is by default Istio system, and then those settings, that configuration applies to across all of your mesh. And then you can also have multiple configurations of the same type or different type applied at the same time, right? And the way that they get evaluated is from the most specific one, so from the workload one up to the namespace wide and then mesh wide, right? And then specifically for the authorization policy, there are, let me see what is the best way to, well, we'll show this it'll be more clear when I show the example, but so there's 3 different actions that you can specify in the authorization policy. There's a custom action that can point to an external authorization provider. So you can also say, hey, I don't want Istio enforcing this. I have my own thing. You can do that as well, right? You can configure external authorization provider. You have OPA running, whatever you have, doesn't matter, right? You can tell Istio, hey, whenever there's a request sent to, you can apply the authorization policy to specific workloads, right? And then you can say, whenever there's a request to any of these workloads, go consult that external authorization service. And that external authorization service will tell you whether to allow or deny the request, right? The evaluation also happens in this order, so it's custom, deny, and allow. And there's a flow chart on istio.io. I'll find it and show it. I think it was too much to put it in the slides here, but basically it goes to custom. Oh, is the custom action defined? Yes, it is. Then go and check what it is, get the result back. Does it allow it? Yes, it allow it. Go back. Is there a deny policy, right? And it checks everyone explicitly. Now, if there's no policy applied, you install Istio, you deploy your clusters, everything's going to be, deploy your workloads. All the requests will be allowed by default, right? It's not going to deny anything. Everything is allowed by default. For the authorization policy specifically, we are talking about a collection or an array of rules that get applied to targets. You specify those targets using a selector, or be it namespace wide or be it mesh wide, and you specify the action, right? So you're saying, I want to apply these rules to all workloads with the label app HTTP bin, and I want to deny the request to those targets, and then you specify the rules when and under what conditions will that happen, right? You can specify the source of the request. You can say, well, I want to deny the request if they're coming from namespace B, right? You can also say, well, I want to deny them when they're coming from the namespace B, but also if they're a GET request on this specific path, right? You can combine that. And then finally, you could also use the when field and say, well, I only want to apply those rules when the request claim with the value of name equals Peter J or whatever, right? So you can fine tune these in a very detailed way, right? All right, so that's done with the slides. So let me switch. Any questions you have, Marino, or anything I missed maybe?
No, you covered it all actually. So that's a really good introduction and level detail of like all the different components from identity all the way to the policy that we'll probably start implementing very shortly.
Yeah. To be honest, the peer authentication policy and the request authentication are, to me, fairly I think I look at them, they're very simple compared to the authorization policy, right? Authorization policy is where you can do a lot of damage as well, I guess, because that's where you configure whether who has access and who doesn't, right? Or what access they have, rather. All right, let me share the full screen. And of course, if there are questions from the audience, feel free to ask. I'll make the fonts bigger. I know that's going to come up. All right, so let's see. Where are we going to take a look? Let's look at the... I have a couple of links that I post that I took in my notes. Oh, okay. This is the one that we'll add this to the repo, I think. But this is I really like this diagram because it explains a lot of like where are specific resources applied in a way, in terms of, is it when the connections are coming in or when the connections are going out? And this also goes to your question earlier. What is it like? What are some of the security aspects that like destination or virtual services can control, right? So just quickly through this. So the external inbound traffic, so coming from outside of the client that gets captured by the proxy, right? If the client is inside a mesh, it's going to be encrypted with mutual TLS. Sidecar is configured to accept both mutual TLS and non-mutual TLS, which is called the permissive mode, right? And you can make it strict, where traffic must be mutually, or disable it, right? The MTLS mode is configured using a peer authentication resource, right? So peer authentication resource on this left side. I mean, affects the things on the left side. Let me put it that way. Then you have the local inbound, local outbound. This is the traffic that happens between the sidecar and your application and back. And then the last one is the external outbound. That's the traffic that's leaving your application, right? And this is where you can control whether you want to forward the traffic as is, or if you want to initiate or originate a TLS connection, right? And this is what's controlled by the destination rule resource, right? You can set it to disable. That means that this proxy here, when calling out, will send plain text, or you can do simple mutual or Istio mutual to originate a TLS connection. So this is useful when day 2, 3, when we talked about service entry resource, right? When we're saying, well, I want to do like a mutual TLS, right, with an external service. Well, you can do it, and this is how you would configure it, right? You would use the destination rule and say, API github.com, whatever I want to do, I want to originate a simple TLS connection, right? Or I want to do mutual even. Or you can even say, I want to do Istio mutual because that thing is part of my mesh, right? And want to use the same root certs, right? So yeah, peer used to type of what type of the MTLS traffic is accepted by the sidecar, and then destination means destination rule controls what type of the traffic the sidecar will send, right? So these are the good. I don't know why I like this one, but it's really it explains it really well. There's some other things here. There's the similar graph for or diagram for the gateways, right? Inbound, right? What happens when you're calling in, and then outbound, what happens when the gateway calls some destination. And then this is a great read. I'll actually post it in the chat here for people to check it out, because I think this explains a lot of things as well. Tells you how it decodes, right? Oh, you want to do TLS connection. What is the pass-through mode? We haven't even talked about that, right? Before. I want to do mutual TLS, you can do it, right? And then still the outbound, and the problem of double encryption, right? Which can happen. Anyway, so that was the first link that I had, but let me go to examples now. Sorry. I actually spent a lot of time searching for this one. I don't know why. It always takes me so long to find it. All right, so mutual TLS migration. So this is the task that will show us how how to configure the workloads to use mutual TLS only, right? And we talked about this one and Grafana. So I have my cluster deployed from yesterday. All it's still running there. So this one is telling me to create the two namespaces. So we'll create foo, we'll create bar, we'll deploy HTTP bin and sleep in both of those namespaces. And one of them, legacy, let me see if we need to. Okay, so both of them need. Oh, see, this one is using the kube inject. I think this should be fixed. This shouldn't be kube inject. So let's do foo.
Can you make the terminal larger?
Oh, even bigger?
Yeah.
Oh, yeah. There you go. Sorry. There you go. Is this better?
That looks better to me, but
yeah.
I'll have to wait for the audience to confirm.
Yeah, I can make it full screen, but I want these like notes to be here so people can see the notes as well. Stuff that I'm actually going through here. So what I'll do is I'll go to the Istio folder because this is referring to the HTTP bin and sleep from the samples, and I don't really want to retype the commands. So yeah, it exists because I created it. Okay. And let's see what we have here. Shay. So almost everything is running. I don't know why these are erroring out, but it's not our problem to worry about. It's not going to affect anything. Okay, so it's these 4 too at the bottom. So HTTP bin and foo and sleep and HTTP bin and bar, right? So we have these two. And then what we'll do is we'll create another namespace called legacy. And then in that namespace, we'll just plainly deploy sleep without any sidecars, right? So there's no sidecars there. And we'll look at the legacy stuff here, right? It's 1 out of 1. And then we look at the foo, you'll see it's 2 out of 2, or bar, it's 2 out of 2, meaning there's 2 containers running in the pod. Do I need to make is this better? I just saw the note.
Yeah, looks.
Comment. Oh, actually, you know what? How about we do this? No, wait. No, was it this one? No, it's the same thing.
That one looks a little bit better.
Oh, this one is a bit better, right?
Yeah.
Yeah.
It's just the also docs page that you have isn't it's small. So I think if we can make that a little better or bigger, sorry. Yeah, that looks good.
All right. Well, hopefully this is better. We are in 1080p, right? So hopefully the quality will be better later on as well once it's processed, right? But all right, so we have 3 namespaces, one with the legacy workload without any sidecars, and then 2 namespaces with sidecars, workloads with sidecars, right? So now it's saying verify the setup. We're going to send HTTP requests from the sleep pods in foobar and legacy to foobar. Okay, so everything should work, right? And the reason I'm not going to parse this command, I'll just run it. Oh, why am I getting 0? That's odd. Well, maybe we should try it manually then. So let's do it. So if I do, it's saying from sleep pods to foobar and legacy. Okay, so let's do, let's call it from foo, right? And what we'll do is we'll say curl http bin.foo. I think it's port, is it 8000? Yeah, it's 8000, and I'll just do headers, right? Oh, namespace. So this is namespace foo. Yeah, so this works. So this is foo from foo, right? Now we're gonna do foo from foo to bar. So this works as well, right? And then I'm not gonna go the other way around because it will work as well. And then we'll also do wait, why am I? Oh, we'll also do from the legacy one, right? So we'll do from the legacy. Oops. I think this is the one that actually matters most, right? Legacy to we'll do HTTP bin foo /IP 8080. So we're calling from the legacy one, the one that doesn't have any sidecars. it's 8,000, not 8080. There you go. So I get back the response. And then the same thing if we call to HTTP bin in bar, right? That's going to work as well, right? So all of them works. I don't have any peer authentication resource. We can check this, right? There's nothing there. So what we'll do now is we'll lock down to mutual TLS by namespace. So what we'll say is everything we want to define or specify, right? So it's saying after migrating all the clients to Envoy, you can lock down workloads in the foo namespace to only accept mutual TLS. So now if we would do, well, this is not a bar. This is a default one, right? So there should be, let me fix it, namespace. Oh, it is, sorry, it is deploying to foo. That's what I missed. Sorry, everyone. Default peer authentication default. Okay, so it is applying it to the foo namespace. I thought it was applying. I was applying it to the default namespace, right? Yeah. So now we applied this peer authentication resource, and we're saying for all the workloads in the foo namespace, right? We're setting the mode to strict, meaning we only allow mutual TLS, right? So now if we repeat the same call from the legacy sleep pod to the HTTP bin that's running in bar namespace, right? This will work, right? We haven't changed anything there. However, if we do foo, this will fail, right? So we get an error because our sleep pod in legacy doesn't have a sidecar, doesn't know how to do mutual TLS, and this destination only allows mutual TLS, right? So this is showing, this is showing the same thing. And then you can do the same thing, right? These are the different levels, right? First one was we applied it at the namespace level. Now this section here is telling us, well, let's apply it at the global mesh level by deploying this to Istio system, right? So let's do that. And foo should still fail, right? Because we have the namespace one, but we also have the mesh one. And then the bar one will fail as well now, because we have the mesh wide thing there, right? So now both of them are, right, enforcing mutual TLS only. And the next step that you could do now is just inject the sidecar proxy to the your legacy pod if you wanted to, right? And then that would work well as well. That will make everything work, right? So okay, so let's delete this. So this was mutual TLS. It's fairly like the resource. If I go back to the resource, maybe I was too quick to delete it, but let me put it here. So this is how the resource looks like. You can specify the namespace here, or I think it doesn't show, but let me find that one. So we deployed it in Istio system to do it mesh wide, and then we deployed it to namespace to make it namespace wide, but there's also a way to authentication. Oh, I should search here, I guess. PeerAuthentication. There you go. I'll make this bigger, right? So applying it to the namespace, strict. Applying it to another namespace, making it permissive, right? By the way, permissive mode is enabled by default, so you don't have to do anything. You don't have to do this unless you are explicitly disabling, making it strict at the mesh level, and then you want to make it permissive for a specific namespace if you want. And then the other one is using the, let me make this bigger, using the selector labels, right? So you can say pods in the foo namespace that match this label have to use strict, only accept mutual TLS, right? Strict mode. And then the other one is port level. This one's interesting as well, right? So you can say, oh, for make it strict for everything except for port 8080. That's where I want to disable mutual TLS altogether, or I want to enable permissive, right? So these are the different, I guess, different levels where you can do this. unset. I think this one is just, will this one unset the top level setting? I don't remember. Let's take a look. What do you think this one does, Marino?
Let's see.
The
MTLS
unset
knows-
one. Unset.
So basically, I would assume that inherit from parent if has one. Otherwise treated as permissive. So if you do something at the namespace, or cluster wide, and then you decide to specify this at a namespace level, your cluster wide would take over because it inherit that as a parent configuration.
Yes, but I think you would do this if you wanted to like explicitly set something else, right? I think policy on inheriting mutual from namespace or mesh settings and override settings for. Okay, yeah. So it's like take it from like whatever the top level is, but then override it just for this one.
Interesting.
Yeah, that's it. I haven't seen this much, honestly, but anyway, so these are the four values that you can set: strict, permissive. You can disable it, right? Or you can do this unset, which is just saying inherit. And then mode. That's what the mode is. And then you can set it at the port level. You can set it on you can select the workload, and that's it. That's the whole of the resources. This one was fairly straightforward. All right, let's look at the next one. And I think I deleted everything. So this one so this one shows us how to set up Istio authorization policy for the mesh. So let's look at this. So we look through this one, we look through that one. We have to deploy book info. Okay, let's deploy book info. Should be quick enough, right? We have this, but I'll run it just in case. Yeah, I have it. And we'll deploy book info. That was fast. Okay. Confirm everything is running. Pods. Yeah, this will be a minute or two. That was fast. All right, so it's running. It's the stuff down here, right? Yep. So ratings, details, product page, reviews, 1, 2, 3, right?
Sidecars deployed too.
Yeah, because it's 2 out of 2. Ignore this error one. What else? Ingress. Okay, yeah, let's do this one as well, since I do have a gateway. Confirm gateway has been created. Okay, I'm not going to confirm this. Yeah. Okay, let's see that it actually works. Well, then I have to do this. And where is it? Let's just do it this way. SVC. There you go. There's my IP. If anyone feels they want to try this out, feel free to do it. And now if we do curl to this IP / product page, right? We should get back a response. There you go. So we got back a response. And similarly, if I would open it in the browser, there you go. That's the same thing we saw yesterday, right? With Marino's demo. All right.
Yeah, the book info app.
All right, so let's do. Okay, so this is the first thing that we'll do is, so we have the application, it's running, right? And what we want to do, we want to start applying some policies, right? So the first thing we'll do is we'll create an allow nothing policy. And this is typically what people would do, right? You would deploy this policy to your namespace and say, I'm not allowing anything here, right? Like deny everything, right? In the namespace. So let's do that, right? It doesn't have a selector, right? So we're applying it directly to the default namespace. And then the spec field, right? Notice the spec field down here. It just has this empty brackets, empty value, right? And that means that no traffic is permitted, right? Which basically it will deny all the requests between the pods in the namespace. And we know we have pods in that namespace, right? So let's do that. So allow nothing was created. And now if we try it, let's go back here and let's refresh. I get RBAC access denied, which is exactly what we would expect, right? Because we're not allowing anything to call that. So next thing we'll do is we'll create a policy called product page viewer that's going to allow the get method to the product page workload, right? We're not going to set from rules, which means all sources are allowed. So allowing all the users and all the workloads. This time, namespace is here, and we're specifying the selector labels. We're saying apply this policy to all of the pods with this label, which is the product page pod. We're saying we want to allow. Remember, we're denying, if you think of it as a layers, right? We're denying everything, and now we're poking holes, right? And now everything is denied, but we're explicitly allowing get requests to the product page, right? From any workload, because we haven't specified the from field, right? So let's do this. Product viewer applied, and now this should work, at least partially. There you go. However, notice that we get errors here, right? We're only allowing get requests to the product page, but if you remember, we have ratings, we have details, we have reviews, right? Those are still denied, right? So this talks about the layering. Let's go back. So yeah, we get this error. And we'll do details viewer, which is very similar. Authorization policy is going to apply to the details pod. It's going to allow it. It's also going to allow get, right? But now we're explicitly saying, well, allow get requests to the details only from this principal. Remember the word principal? That's the service principal. And look at the name of the service. That's the secure name of the service. Cluster local namespace default service account book info product page. So this information here, this string here, is the thing that I was talking about that gets extracted out, and then you can use it here in the authorization policy, right? So this is locking it down even more. This is explicitly saying, yes, you can do get requests to details, but only the pods with this service account, with this identity, can do that, right? So if you wanted to call it directly from the gateway or from another cluster, it's from another workload, it's not going to work. And the other thing we'll do is reviews viewer, which is the same thing, right? It's saying product page can call app reviews or make get requests to that endpoint, to that workload. So let's do this one as well. And now if we try it, so this is what we had before. Now it looks a little bit different, right? Now we get the ratings here, right? We see the ratings, we see the review. Oh, we see the reviews, we don't see the ratings, sorry, right? There you go. Yeah, that's what it is. Ratings doesn't have permissions. Of course, we have to explicitly allow reviews to access ratings. And this is, again, following the same pattern of poking holes into our deny policy. Apply to ratings, allow explicitly to do get requests from the review service. So review service or review pod can call the ratings and make get requests there. Let's copy this one. Okay, and let's try this out. And now everything works as it did before without any policies, right? The difference is that we had, oh, it's authorization policy. Is it authpol? No, it's not.
Authorization
right?
policy.
You have to spell it out, right?
Yeah. It's not like netpol.
Yeah. Policy. There you go. Right. So we have these policies applied here. Now, if I would create like a sleep pod, right? So let's do. By the way, kbash is just my shortcut for creating a curl or a sleep pod in the cluster, right? So if I would, I'm inside the cluster now, right? So if I do, I just show you, right? So this is the pod that I am in. So if I would try to make a request to well, if I remember what the service names were. Product page, right? So product page 9080. And what is the / product page, right? Page. Why is this working? This shouldn't be working. That's odd. This is what happens when I go. Why can I? Oh, because, wait, did we? Allow nothing is applied, right? So this shouldn't. Anyway, I'll have to figure out why was that working?
So let's look at your curl again.
Oh, it was just curl. Let me go back to the. So curl product page, right? 9080 product page, right?
Right. Okay, so it goes through. So that's coming from within the same namespace.
Yeah, which I think we applied that, right? Authorization policy. Allow nothing, right?
Yeah. So
let's
go click on, look at the product page viewer one.
Oh, this guy. Oh, yeah, you're right. That's why. Yeah, you're right. I think this one is, yes. Yeah. So this one is allowing, this one doesn't have the, it's not explicitly setting the source of the, So if we would change this one to specifically say, let's actually go, let's just do this, because I'm not going to be able to sleep if I don't do it. This guy, right? So if we would update this one, and I just do it here. So we're going to update the product page one to, and add this from section. And we'll say allow, and we only wanted to allow to go through come from the Istio Ingress gateway, right? Because that's where it's coming from, right? So I'll update this principal name to Istio system service account. And then I don't remember what the service account name is there. Get deploy, Istio Ingress gateway. Okay. YAML grep service account. I think it's something like that. Yeah. So this is the service account name. So we'll use that. Istio Ingress Gateway Service account as part of our principal, right? So in this product, the reason it worked before, as Marino figured it out, is because the product page was allowing GET requests. It didn't check from where, right? It was allowing it from anywhere. But now we're saying only allow it from the Ingress Gateway, right? From the outside. So if we apply this one, so it's configured. So this should still work. Shouldn't be any changes here, right? But now from the curl, there you go. So I get
timing out. Yeah.
I get, there you go.
Or forbidden. There you go. 403.
Yeah. There you go. So I get RBAC access denied. All right. So we figured this one out. That's good. Yeah. So this is, if I go back to the only thing that we haven't mentioned here is the when section. And I think when section, let me just take a look at the links. Yeah, that one might be in the authorization policy. So let's the request let me just check if it's here so we can show the example of when. I'm trying to do this here. Yeah. Also, let's do authorization policy. When you're doing the exam, the documentation under the reference config is typically very useful, because this one explains the whole resource, right? And all the different fields. This one even explains how the rules are evaluated. There you go, right? So this would be an example of an authorization policy that uses the when field as well. So if we read this one, what is this one saying? So it's applied on the foo namespace. It allows, specifies an allow policy for all the workloads in that namespace, and it's saying from principal from the sleep pod or from the test pod, right? Either of these two, to either get/info, and then you can use the star there, right? To whatever follows after that, or and the post on the data, right? So it's allowing this from this when the issuer claim from the request authentication is set to accounts.google.com, right? So this would mean someone signed in, someone has a JOT token that was issued by this URL, right? And that token is valid, and they can do this, right? That's how you would read this. The other thing is to know the and or semantics in the rules. So let me see if I can find an example there. These are some of the things that I always have to Google anyway. So, okay, match will never occur. So let's go in the rule. At least one. Empty rule is always matched from. So let's do semantics. Does it mention it here? Don't remember. I'll have to look it up. Let's see. Denies the request from the dev namespace on all workloads. So let's see. Okay, so this is a better example. So it's allowed. Or okay, so if you have it like this, it's or. If we would remove this dash here, it would be and, right? So in this case, it's saying the request can come either from sleep or from the test namespace. However, if we would remove this, it would say it has to be both of these have to match, right? And then the same thing here, right? It's or get or post. I guess it wouldn't make sense to have an and here because you can't have a get request and a post request at the same time. But there are other things that you can set here. So let's take a look at those. To operation, right? So you can specify hosts. You can, and each one of these has a negated version as well, right? So you can say, so from hosts or not from hosts, right? Negative matches. Same for ports, not ports, methods, not methods, right? You can say, I want the method to only allow the get, but you can also say, I don't want to allow get, but I want to allow everything else, right? So it just allows you to do the combination there. Condition is, this is that when section, and here's the list of attributes that you can use to do a when condition on that last portion, right? You can use the request headers. You can check the source IP, remote IP, source namespace, principal, authenticated principal, right? This is what comes from that JOT token from the request authentication resource that gets extracted. Audiences, this is just the claims, right? Claims there, claim, just generic claims, any claim. Destination IP port, SNI, and then this is an experimental one, which it's experimental, so don't use it. At least not in production. All right, so let's see if we want to go through JOT one. Yeah, we can do this quickly. So let's see. Just want to go back so I can clean up. So we'll do delete authorization policy. I think this will work, right? Yes. And I'll just delete my default namespace and then. Oh, I can't? I don't know that. That's interesting. Can I do delete deploy all? Of course. Perfect. That will leave me services around, but hopefully they're not gonna clash. All right, so JOT tokens. Let's do that. So let's do namespace foo, and we'll have HTTP bin and sleep. Let me remove this one. And we'll just verify that sleep can talk to HTTP bin. There you go. We get back a 200. So that works fine. So now what we'll do is we'll create the request authentication that will be applied. So this is how you read this select, or this is at least how I read these, both in the request authentication and the peer authentication and the authorization policy. You're saying, what am I applying these rules to, right? What are the workloads I'm applying these rules to? In this case, it's the HTTP bin, deploying it to the foo namespace. And we're specifying this JOT rules. We're saying that HTTP bin only accepts JOT tokens that are issued by this issuer. And then we're also pasting in a link to the keys. So these are the public keys. Not that it matters. It's not going to tell you anything, but these are the public keys that Istio knows how to use in order to validate the token, right? So let's do this. Let's apply it. So we have the request authentication. And now what we'll do is we'll make a request and we'll send, notice the authorization here. There you go. Notice the authorization header. So we're going to set authorization bearer and just invalid token, something, right? Something that's not valid. But what we're doing, we're sending a request. It's just a long way to say we're sending a request from the sleep workload to HTTP bin. And we're setting the authorization bearer authorization field to bearer and some invalid token, right? Just to show that this will fail, because we want to make sure that the token is issued by this issuer, right? So let's do this. So we get a 401, right? So this is expected. This fails. Now, without, this is an interesting one. If we don't specify anything, any authorization headers, the request will be let through, right? And that's because there's no authorization policy, right? So one thing that I should have stressed earlier, but I don't think I did, is you can have an authorization policy without authentication and vice versa, but they're useless, right? Because this is a prime example, right? What good does a validated token give me if I'm allowing all access, if I'm not locking down access, right? So what we could do in that case is we would create an authorization policy, and we would say only allow, and this should be familiar, this is what we did earlier, right? Authorization policy, apply it to HTTP bin, allow, and then explicitly say, well, I'm going to allow the request, notice this time, from the request principals, not the principals. So principals are the services, right? Request principals would be the users, right? So we're saying allow request to HTTP bin only if the JOT token principal, right, is this guy, right? Is this, I guess, request principal name. And this is said, we'll look at the token before later, right? So let's do this. Now, if we repeat the previous one without an authorization header, this one should fail now, right? We get a 403, which is what should happen, right? So the invalid one fails. The request without a token will fail as well. Now let's actually try that we get a valid token and it actually works. So I'll just run this thing here, which is just going to generate a valid, or maybe not. Is it -d -d what? Wait.
-dd.
No, that's what it was. It was there was an extra. There's an extra like see minus here at the end.
Oh yeah,
There's a free documentation bug if someone wants to go and fix it, and I'll paste this in the. It's I mean it is the October, what is it, Hacktober thing, right? So maybe it will count towards your t-shirt or whatever they're giving away. But anyway, so this is the token. This is the decoded token, right? And notice the issuer is set to testing at secure Istio, and then the subject is set to the same value. And that's the same value, I'm trying to scroll higher, that we have here in the request principal. And that's because the request principal is made out of the issuer / subject, right? I just want to show the token. I'm sure everyone, well, if not, this is how a base, this is how the Jot token looks like typically. You can go to jot.io. There's a debugger here, right? And you can paste the token and it'll show you what the payload is, right? Notice foobar is just some claim, doesn't matter. And then issuer and subject are set to the same value. So now we have that token. Let's go back here. Nope, this one, right? We have the token, and now if we send that request, notice this time we have authorization bearer, and now we're specifying that token there. And this time it'll work, right? We get back a 200. So yeah, we tried this one without a jot. It's going to be denied, right? We showed that one before. And what is this one doing? Authorization. Oh, this one is, yeah, this one is adding the when statement here. Let's just do this one as L. And it's saying allow the request principal, allow the same request principal, but only when the group claim is set to group 1, right? Or one of the values is group 1. So let's do this. And I don't think we had group 1, right, on this one. No, it was just foobar. So now we've updated this. We strictened it a little bit, right? And now we're getting, let's just try it with the previous token. This should, where was it? This one. This should fail now, right? Yeah. The stuff that worked before is failing now because that that token didn't have the group claim set to that value, right? So we'll grab another token. This one has the same issue. There you go. And this one has the groups set to group 1 and group 2, right? And notice that the values here, it's just going to match 1. It doesn't, you don't have to specify all of them, right? We're saying just 1 is enough, right? When one of them is matching. And now if we retry the request, and this time we're sending this token group authorization, and we get back a 200, right? Yeah, and the one without fails, right? Which is what we did already. So yeah, so this is, I think this example is good. That shows how you can like match, well, how you can use the when. But what we could do here if we wanted to is we could also say, I'm not going to apply it because I just deleted the namespace, but I'll show you here. Right. So we could have something like this, right? We could say, well, allow the request to HTTP bin when the request principal is set to this value, or, right, source. Or actually, we can do and, right? We can say and the principal, or do I have to do it the other way? Principal. Oh, might be here. Right. Yeah, you're right. Like this. And the principal is, let's say, Ingress Gateway or whatever, right? So this way might be an incorrect syntax, but please look it up, right? But it's the idea that I'm trying to show here is you can now combine the request principles, which are talking about users, with principles, which they're talking about services, right? So basically saying, allow request to HTTP bin if the request principal is set, if the user is logged in and it has this principle, and the request is coming from this service, but only when the user also is part of this group one, right, or has that claim set. All right, how are we on time? Let's see, what was the other thing? Yeah, I just want to mention this. I know we talked about the securing ingress a little bit, right?
The gateway TLS.
Yeah, the gateway TLS, but there's really, I mean, to be completely honest, there's not that much to it. Let me see, we can quickly go through this one. I'll deploy HTTP bin, and I hope I have the right version, Libre. Yeah, I think I do, so it should work. So this walkthrough here, it's basically you can create this. It will create the certs, right? So you have to create this self-signed certs, right? And I'm just clicking through this quickly, and then I'll explain. I'm not going to explain the commands, but just explain briefly what this is doing, right? So this is assuming that you what you would have in this case is you would have a domain name called example.com, right? Let's say that's the domain name I own. I have example.com. And typically these certificates, you would probably get them through Cert Manager with Let's Encrypt, right? Or something like that. Or maybe your domain registrar is nice enough and they'll give you your certificates for free, right? So you can have those as well. But the idea here is, let's say I have a website. I want to run an application that has one portion of the application as a front end website, and I want to host that on http bin.example.com, right? So I have the certificates, right? So what do I need to do to get that HTTPS, get this thing here, right? This nice connection is secure padlock when someone goes to http bin.example.com. Well, first off, you have to bring in this, let me go here. You have to bring in the key and the certificate that we just created, right, as a secret. So there, Kubernetes has a secret resource, and that secret resource can be of type TLS, right? So this is what we can do. So let's do creating a secret. The secret is there in the Istio system because that's where the ingress gateway is running, right? What did I want to show? Secret Istio system, so HTTP bin credential, right? So that's the one that we've created. And then the next thing is configuring the ingress gateway. And let me just make sure I don't, of course I have it. So book info-gateway. Let's delete this guy. All right. And just make sure, let me delete the VS as well. This was a leftover from before. There we go. Now, should be fine now. Yes. Okay. So next thing we're doing is we're configuring the gateway. We've shown this yesterday a little bit, I think, and the day before. Targeting the ingress gateway that has the Istio ingress gateway label. This time we're setting port to 443 because we want to configure HTTPS, right? And we're setting the TLS mode to simple. And then this is the secret name. This is the pointer to that secret that we just created. And we're saying we're doing this for this host. Right? So Nita is asking if there's a, yes, there's a way. Yeah, yes. At the ingress gateway, I'm not 100% sure, but there is a way that you can configure the cipher. So TLS version by default is set to 1.2, and there was a new feature in 1.19, and I'll just go to Solo blog because I wrote the blog post about it, and that one talks about the I just find it about setting the ciphers, but I think it was, if I don't, when did I write that? No, was it? Oh, there you go. There you go. I was looking for my face. There it is. Yeah, so there's a support that got added called the cipher suites. And with the cipher suites, you can control the cipher, right? If you're using TLS 1.2. With TLS 1.3, there's the ciphers are not configurable. So, but anyway, this is, I'll post a link in the chat here. We also have labs for that one. So if you click, this one here, check out this lab. I'll paste the lab as well. You can actually go through it and try it out on Solo Academy. All right, where was I? Here, right? Yeah. So let's apply this. There you go. So we have the gateway configured with this credential certificate. And now we also have to configure virtual service, of course, right? Otherwise, it doesn't know where to route the traffic. And this one is just saying for this host, attach this gateway to it. And then if it matches /status or /delay, go to the HTTP bin service on port 8000. Let's do that. Finally, okay, that's fine. And now if we make a request, let's see, ingress host. Oh, I knew that this will be, let me get so get svc istio system. So my ingress host is this. I'll do export ingress host. My ingress port is going to be 443, right? Secure ingress port. And the reason, I think the reason sometimes people get very confused with how to how to do TLS termination, how to add a certificate to your website, right? In a very simplistic term, is because there's so much like, oh, let me create a privately signed certificate and all this, and then now I have to have this magical curl command that I could use to access the thing. But typically, what you would do here, if this was a real domain, you would just go to http://bin.example.com and it would magically work. Well, not magically, it would just work. So let's do this, and this should, or maybe not. Secure ingress port. Okay, secure. I thought I said it. Port 3. There we go. Right now it works. So what this is doing is saying, I want to set a header of http://bin.example.com, and then I'm saying, well, resolve http://bin.example.com :443 to that public IP, external IP address of our ingress gateway. And also, I want to provide you with these CA certs, right? And then I'm making a request to http://bin.example.com :443 status / whatever. That's just a call, right? So what this is the magic part here, I guess, is just saying, hey, if I'm calling this, but then actually replace it with the actual IP address, right? And then specifying the certs. And if we wouldn't specify the certs, we would get like a self-signed certificate, blah, blah, blah. It's not like an error, right? Or a warning, I guess. But you can see that the certificate was used. You can see the subject. This is the thing that we created at the beginning, at the start, and that the certificate was okay. Yeah, so this one was fairly, I mean, it's, as I say, the hard thing is, I mean, the harder thing to understand is when there's, oh, I need to create like self-signed certs. Oh, but to create a self-signed certs, you need to, do all this, right? It's just a lot of commands, a lot of files and everything. What I'm trying to get at is just understanding the basics is useful as well sometimes. And sometimes it's just abstracting these things out and thinking about them. Oh, these are like, okay, it's certs and key. I'm not saying it's not important, but it's not important for what I'm trying to do right now, which is I want my ingress gateway to use that cert. And if we're talking about that, how does an ingress gateway use a cert? Is very simple. It's you create a secret, you reference the secret in the gateway. That's it. That there's no other magic that you have to do. The way that you would do this, like realistically, is you would probably have like a cert manager or something running. Cert manager would be configured to talk to Let's Encrypt and do all the magic to get back the actual certificate, right? And then what cert manager would do, it would drop the certificate, it would create the certificate as a Kubernetes secret. And then you would still have to do the same thing you did today, right? Just reference that secret, and that's it. So it's not too crazy. I don't know what this next one is doing. Oh, it's just different keys and different things. And then multiple hosts, it's the same way, right? You would do it the same way, assuming you have like http-bin-example.com, which we have today, right? And then you want to do hello world example.com. Just add another section, right? It's just another section with a different host name pointing to a different credential, right? And then you would also have to create a virtual service, right? That attaches it, and then this works. Mutual TLS, highly doubt they'll ask this on the certification, but it's still, you can do that as well if you want to, right? So you can configure your gateway to perform mutual TLS with whoever is calling from the outside, right? This is the only difference, right? You set the mode instead of simple, set the mode to mutual and say, hey, I want whoever's going to be calling you is going to be doing a mutual TLS handshake, right? So the previous request would fail, of course, because it doesn't know how to do mutual TLS. But then when you would pass in the actual certain key, so the server side knows how to do mutual TLS, then it would work, right? But from the Istio's perspective, I guess, those are the two settings that you have, pretty much. All right. One other link that I want to show is, let me do here. And I'll include this in a GitHub repo. We'll include it. Security problems. These are interesting to go through, right? Because this will teach you how to like troubleshoot some of the things you might run into, which some of the things here could lend well themselves for being questions or like scenarios in the exam as well. So I would definitely look through these. There are some like Envoy filter stuff as well, which I don't think is going to be on, but this is the one that I brought up yesterday, right? Make sure there are no typos whenever you're copy pasting stuff. Not using HTTP. Yeah. So this is an interesting one to review, and then of course the best practices one, which gives you a lot of, actually explains how things work as well, but it gives you some of the best practices, such as using default deny patterns, right, where we're denying everything and then poking holes and explicitly allowing just specific things, right? So yeah, and then lastly, this is the last link I'll share here, and it'll be in the repo as well. Just the security configuration page. I think this would be the most useful thing that you would have in the exam, probably, right? If you're trying to configure something, well, go to authorization policy, right? And this is the same page I was on before, right? Where it actually explains the whole API, right? Oh, I need to know the from, right? Oh, okay, from source. What can it be from? Oh, it can be principal, request principal, namespaces, IP blocks, all these things that I can configure. This is basically the reference config reference page, and I think there are other reference pages for other things as well, like traffic management that you can go and look up. Istio operator as well, right? Or global mesh option. Definitely a good page to bookmark or know how to find very quickly. So yeah, I think we can open for questions if anyone has any questions. I don't have any demos. I think we covered most of it, right, Marino?
Yep, I think you covered all of the main critical topics of the exam and then some. So I definitely encourage everyone to go back and review the video, follow along. Even yesterday as well, like we went through a number of traffic management scenarios and capabilities. And a lot of that is foundational for really making sure you pass that exam. Yeah. So tomorrow, what we'll do is there's a couple of scenarios that we want to cover. The first one is onboarding a virtual machine artifact into the mesh. So it could have a workload, it can participate in the mesh. We can see how some policies and TLS are present. And then we'll talk a little bit about some of the WASM and Istio capabilities that exist today, and maybe look at a WASM filter. And then finally, there's a number of troubleshooting sections we should probably go back and review and just kind of get a sense of how we would work through an issue in Istio. What are some of the tools we would use? Where would we look? Maybe some of the logs might be telling us certain things. So that's what we'll visit tomorrow. Tomorrow, though, we will be going back to the original time of 12 p.m. or 9 a.m. Eastern. 9 a.m. Pacific, 12 p.m. Eastern.
Yes. Yeah, exactly. So tomorrow is going to be the advanced section, right? What's called advanced in the certification, and yeah, it's going to be a good section to close out the whole week of these topics. We also, I don't think we've mentioned it too much, right? We do have a GitHub repo, so we'll be updating that, adding things to it, things that we discussed, any links and everything. So make sure you visit that one. And we do have another thing that's coming up, but we'll keep it under the wraps, right, Marino? Because that one's gonna be not gonna be next week, but yeah, there's gonna be another awesome thing that we'll do soon. So
yeah, exactly. I mean, one thing that I just want to keep in mind is that folks might start preparing for this exam. I just, as Peter was going through the demo, I just decided to go sign up for the exam, and I noticed that you cannot book the exam yet. Like, there's no option to schedule it. So I'm waiting for that. Once it becomes schedulable, I'll probably book it for closer to the end of the year. Just giving myself some study time and whatnot, but let you know how that experience goes.
Yeah. All right. Well, that's all for today then. Thanks everyone for joining. Thanks everyone for listening. Feel free to reach out if you have any questions. And yeah, we'll see everyone tomorrow then. Bye.
Yep. See everyone. Bye.
Bye.